we've been talking about Newton's laws. We've been drawing free body diagrams and whatnot. So let's get right to the good stuff, and let's do some problem solving. Okay, so I'm going to give you 4 sample questions. I would like to encourage some of you to start modeling how I am organizing my solutions. Okay, in other words, this is the way I would like to see it. Okay, so let's have a look at example 1 right here. Now I've also given you a handout so you don't have to copy down the question, you just have to write down the answer. So it says example number 1, a constant force acts on a 12 kilogram mass, changes its velocity from 4 meters per second to 18 meters per second in 3.5 seconds. What is the force? What is the force? So we're looking for F. What do we know? We know a mass. When I say that it goes from 4 meters per second to 18 meters per second, what 2 velocities are those? What would you call those? 4 meters per second would be the initial velocity, and the 18 would be the final. And the 3.5 seconds, Riley, what would you call it? The time. Okay, so given M and VI and VF and T, I need to come up with force. Now, what formula do you know that has force in it? F equals MA. Does F equals MA have M in it? It certainly does. Does it have A in it? It does, but we don't have A. Can I get A from this stuff? Yes. So, should I write down F equals MA first? No, because that's the last thing I want to write down, because I'm asked for the force. That's the last thing, right? So I don't want to write that first. Okay, I need to determine the acceleration first. All right, how do I get acceleration? Well, remember, acceleration is what? Delta V over delta T. Do I have delta V? No. I don't even have it yet. So the first thing I got to come up with is, what's my change in velocity? Change in velocity is final minus initial. In this particular case, that's going to be 18 minus 4, or 14. The velocity changes by 14 meters per second, right? Now that I have that, what can I do, Chris? Now I can find my acceleration, delta V over delta T. So that would be 14 over 3.5. Notice how my solutions go. Here's my one answer, then I move over. There's my formula, my substitution, my answer. 14 divided by 3.5? I think it's 4, is it not? Yeah, it's 4. And now that I've got my acceleration, where does it go? It goes in here for A. Do I know my M? I sure do. So that's going to be mass 12 times acceleration 4, or 48 newtons. And you'll notice that my solution ends up in the bottom right-hand corner of my solution space. That's where I look for it as a teacher. Don't have your answer up here somewhere.
Can't you circle it?
Okay? Well, but start organizing your thoughts. Get them in the right order.
What do you think back?
Did you notice how I forced you to think backwards? I said, what is the force? So the last thing you should write is F equals MA, right? The question is, what is the force? So that should be the last thing you write. If you want to write it first, you got to write it over on the right-hand side. And then think to yourself, what do I need, right? Like you could write, if I could in another color, you could write over here F equals MA, right? And then what do I need before that? I need A equals something, right, to get acceleration, because I don't have the acceleration. I could write A equals delta V over delta T. Oh, and then I need, before I can do that, I need what delta V is. Did you find it, Courtney? Yep, that's it. Okay, so if you want to think backwards, rather, that's great, but then work from right to left, so that when you organize your solution, it's back to me in an organized fashion. No, it's not. Okay, let's have a look at example number 2. This time we have a 100 kilogram crate. It's being pulled in 2 directions with different forces, 250 newtons south, 150 newtons east. If the force of friction is 50 newtons, what would the acceleration be? I think we need a diagram here. What do you say? Now we got south and we got northeast. Are we going to be looking at a side view, Riley? or are we going to be looking at a top-down view, like from a treetop kind of view? Top, right? So I'm going to draw my 100-kilogram crate like this. 250 newton south. Brett, you need to worry about your test and not worry about this, because I can see you like, I know it is. $250 newtons south, 150 newtons east is going to be like this, right? If there was no friction at all, which way would it go? Southeast, something like this, right? Something like that. Now, if there's friction, which way is the friction going to be? Exactly opposite that, right? That's going to be my friction force. That's going to be my 50 newtons. Have one of those there, Jesse. Okay, so thinking here now, what would the acceleration be? Well, F net equals ma. Do I have the mass? Yes. I have the mass. I'm going to have to first solve for?
What's F net? What is that?
F net.
Oh,
The sum of all the forces. I have to add up all the forces. How do I add up 150 and 150 and 50? Do I just go 250 plus 150 is 400 plus 50 is 450? Is that what I do?
no.
Would I go 250 plus 150 is 400 and subtract 50? Because it's friction?
Yes.
No.
Can it?
How do you get 50 as the friction?
It says,
To
Friction force is 50 newtons. What I need to do is, because the 250 and the 150 are vectors, what do I need to do? I need to put them tip to tail,
why do you do that?
because they're vectors. I need to put them tip to tail and find this red resultant. Okay? So step number one would be to do this, to go call this F1, call this F2. Now, what are we going to call that?
X. Call it X.
It's the resultant of those two, is it not? Can we just call it resultant for now? You could call it resultant force or something like that. So the first step is going to be going R squared is equal to F1 squared plus F2 squared. So in this case, that's going to be 250 squared plus 150 squared, giving us an R value of 291.5.
Is that square root of 2?
I square rooted that for you, yes. 291.5 newtons. This is example 2, Jesse. So that's just the sum of the 250 and the 150. Now what do I do with the 50? That's just the resultant of the two forces. So now my F net, right? My net force is going to be my resultant force plus my friction force. Now when I say plus, what I really mean is add them as vectors. So that's really 291.5 minus 50. Do I need to put them tip to tail or anything like that? No, because they're simply going to be opposite direction like that, right? One's positive, one's negative. Right? So just subtract 50. So it's 291.5 subtract 50. That's 241.5 newtons. Okay, do we have one more step to do? That's just the net force. I need to find the acceleration. So now I'm going to write F net is m over a. No, because I'm asked to find the acceleration. So what's my net force? 241.5. The mass is 100 kilos. In other words, divide by 100. So you get 2.4 meters per second squared. Am I done that question?
Yeah.
What's the general rule about problems, Devin, that have a east or south or north in them?
You have to write the direction.
Usually, if I give you east, south, or north, that means that you probably have to include that in your answer. Do we need to include it in our answer? Yeah, acceleration is a what kind of quantity? It's a vector quantity. It needs a direction. So what direction is the acceleration? Well, it's in whatever direction that resultant force was, is it not? Right? So it's that angle right there that I'm interested in. So theta is the inverse tan of opposite over adjacent. Now the F2 is the 150. 150 over the 250. What am I finding? The angle of the acceleration. I need to know what direction the acceleration is going. It's going in the same direction as the resultant force.
It just says find the acceleration.
Yeah, acceleration is a vector. So it's 150 divided by 250. Take the second function tan of that. I get 31 degrees. So that's going to be south 31 east. South 31 east. Now, how much would all that be worth, do you think?
Probably like 5.
Yeah, probably 5 if I gave you one for the diagram, right? 1, 2, 3, 4, 5. Now, I just see that I haven't had the record button on for the last couple minutes, so that's unfortunate for people that are away. We're talking about 250 newtons is being applied to the sled. We have to find the horizontal component and the vertical component. How do I find in a triangle, Devin? In a triangle that has a hypotenuse of 250, how do I, and an angle of 30 degrees, how do I find the horizontal component? How do I find that bit right there? Okay. Okay, so adjacent, is that not adjacent to that? What's the triangle grade 9 trig formula for adjacent? Which one has adjacent in it? Sine, cos, or tan? You need to know. SOHCAHTOA. Which one has cosine in it? SOH. Sine is opposite over hypotenuse. Ka is adjacent over hypotenuse. Tangent is opposite over adjacent. So which one has cosine, or which one has adjacent in it? The cosine, right? Cosine. No, they don't. This one doesn't. But do we have the opposite? The opposite is the FV. I don't have the opposite. I need to know the one that has hypotenuse in it. So cosine theta is equal to adjacent over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. Cosine 30 degrees is equal to, what's the adjacent side, Terry? I'm pointing to it for you, for your assistance. F horizontal, very good. So the adjacent is FH, and what's the hypotenuse? 250. 250. Okay, a lot of steps, yeah. Okay, no. Okay. So yeah, so the 2 happens to the 250 goes up here, right? Yeah, switcheroo. Well, no, we're not going to switcheroo. We're just going to move the 250. So it's 250 cosine 30. I got to solve for FH by itself. So FH is equal to 250 cos 30. Which is 250 times the cosine of 30 is 216.5. That's my horizontal component. So of the 250 newtons, 216.5 newtons actually does what? Pulls it sideways. 216.5 newtons actually pulls it sideways. Now, is there any other force left and right on this thing? No, it's in fact frictionless. If there was friction, it would be which way? Natalia, which way would friction be if there was friction? That way. And what would I do with that? Say friction was, say, 10 newtons. What would I do? Subtract it from here, right? That's what I would do. But in this case, there is no friction. So because there's no friction, we're going to say, therefore, F net is equal to 216.5. Okay, now I've got my F net. What do I do? Follow the backward steps. Follow the backward steps. There's the formulas. You already figured them out. Follow the backward steps. The next thing to write is A equals delta V over delta T. We are going to do the math. But we have to follow these steps. Eh?
Wait. We need to find acceleration.
Oh, we do. You're right. Right, you are. I'll just move that one over then.
But we can't move it over.
You got a pencil.
I got no eraser.
Oh, well. F net is equal to MA. Thanks, Courtney. So I've got 216.5 is equal to, now what mass do I use? I got two masses here. What mass should I use? Should I use the 50 or the 15? Both. They're together, right? Exactly. It's a 65 kilogram mass. So I get an acceleration of 216.5 divided by 65, 3.33. Hey. Okay, so now I got my 3.33. Devin, what's the next step in the line here? Devin, what's the next step? I got A equals 3.33. Now do this one, right? So you're going to write A equals delta V over delta T. You're going to go 3.33 is equal to delta V over, what's the time? I solved this. 216.5 equals 65A. I solved that by dividing by 65. Right? Riley, are you watching? Because I expect you to know how to do this later. No, the time is 3 seconds. So I get a delta V of what? 9.99 meters per second, right? My velocity changes by 9.99. Now what's the next step? Just going across here, right? Delta V equals, now actually if you stop and you think here, what's the initial velocity? 0. So really, do I really need to do this step? I can simply say that therefore the final velocity is 9.99, right? Right? Because the initial velocity is 0, right? So now how do I find the average? V bar equals VI plus VF over 2. 0 plus 9.99 over 2, giving me an average. Can I just take that 9.99 and round it to 5 to 10? You okay with that?
Yep.
And say that divide by 2 and just get 5.
I like that.
I think we've shown enough work here. We'll just go to 5. And I'm almost done now, aren't I? Huh?
That says VIT. Yes.
No.
VI plus VF.
Average velocity, VI plus VF over 2. That's why it's so important to stay with us, Riley.
Well, I'm trying.
I know. It's important to listen to what I say when I write it. VI plus VF over 2.
You got a split.
How much more do we have to do? Just one more, right? We've already found the final velocity and the distance travels in 3 seconds. V bar equals D over T. I'm going to give myself a little bit more space here. I'm going to write Riley V bar is equal to D over T. What's the average velocity? 5. I'm solving for distance. The time was 3 seconds. The displacement was 15 meters. That's a lot of steps. It would be 1, 2, maybe 3, 4, 5, 6, maybe 7.
Should be like 12
No. What would I give the other 5 marks for, Chris?
for being hard.
No.
For remembering the formula.
Okay? Use that as a framework, you guys. Use that as a help.
Thanks, Mr.
My
Van.
brain is-
Okay. I think I'm going to leave out. I will do example number 3, or the last one tomorrow.
Thanks, Mr. Van.
Okay? Here's some problems you can work on.
Thanks, Mr. Van.
You're welcome. There are answers on the backs. You'll notice, have I showed you this yet?
No, but I have one.
Okay, you'll notice that the QR code is on the bottom here. If you happen to have a smartphone, okay, or if you happen to have an iPad, or if you want to borrow one, okay. then all you do is, take a picture of it,
I have a Samsung.
and the solutions come right up on your screen. It's just pretty quick.
Look, man, I got it.
Okay?
Look right there.
There you go. Works good.
The one Zach had the other day kept slowing down.
I know what's happening. Yeah, I don't know why it does that.
Why does it do that?
I don't know.
Because then we can't see it.
Well, it said if you download it, it actually works.
How do you download it?
I don't know.